Okay, it feels almost unfortunate being back so early, but I want to get this over with. I've been doing multi-threading for, let's see, yesterday was Friday. Okay, so on Fridays I stream at 8:30 p.m. I've been doing multi-threading for 26 hours and 16 minutes. And I hate it so much. It sucks. It's the worst. Oh my god. It's the absolute fucking worst. Um, really, just because I don't know. Yeah, you both got your streak at the same time. 5 and 25, damn. Dedicated. Alright. Fuck's sake. Alright. Alright, here's the deal. Yesterday I built signals in a multi-threaded way. I was talking about threads. I'm not really using them to do background work necessarily. I'm using them as separate entry points into my program. Right, so this is probably going to be helpful to draw. Kind of this, yeah, sure. But, you know, I have my program. This is its main function, right? This is the entry point. This is, int main first instruction. And then you got, return or halt, the syscall that closes the main thread or the program, right? But what if your program receives a signal? Well then, you need another entry point into a completely isolated section of the program that just handles, well, it's not completely isolated section of the program. It can communicate with this one. You just have to be careful in doing it. Which right now I'm not, but whatever. I don't really need that right now. It's the last thing I need, as a matter of fact, is to care about that. But yeah, you need an entirely different entry point with its own stack, its own execution, so that it can handle your signal. And again, they can share memory between them if you want, but it's not really necessary. We can give them a little bit of shared memory. In my case, they share a boolean, which only one of them is allowed to write to well, both of them could write if they wanted to. Only one of them really writes to it. Why am I wearing this? It's just gonna get hotter in here. So yeah, so far so good. Then there's user space. File system in user space. I want my system to work maybe a little bit like a microkernel. I wonder actually how much code I'm gonna write in this stream and how much I'm gonna plan. Hopefully I'm able to do both, but I do need to do some planning first, because I need to consider how do I want to do this. Right. File system works in the same way. Again, let's ignore the shared memory. You have your main program with its main execution doing its thing, and then you have over here the entry point to the file system, the one that handles the file system stuff. Cool. How do you handle it? With a completely separate execution context that only gets called when you need that file system, right? If my file system is /terminal, then whenever you access /terminal, it's provided by this process. So I will use this only when /terminal is needed. I have the code for that. The problem is there can be a second program, and it is the one that needs to access /terminal. Let's call it /shared. Makes more sense. /shared. This program is the one that accesses /shared, which is provided by this program. The solution here seems simple. Just send it over to this function. Easy. Except it isn't. it isn't simple. There's a whole behavior to the file system, which means that to mount /shared onto the file system, for example, we run this code. Anyway, at least I fixed the issue that I was having before, so that's good. But the way that I fixed it, I don't like. It required me to schedule this thread so that when it starts running, it is not guaranteed to run all at once. Instead, it can run at multiple times, multiple executions. And that is a problem. That is certainly, definitely, not what we want. But the timer was being stupid. I don't know how else to put it. Okay, Rust. I've seen this message. No, get rid of it. I've seen this message saying that it was downloading the Rust whatever for a while, and it's really annoying. Get rid of it. And that's not Rust's fault, it's Zed's fault. Anyway. The thing is, now it's not like this. Now it's going to be fragmented. So we get this executes for a little bit, this executes for a little bit, this executes for a little bit, some other process executes for a little bit, so this executes for a little bit. Eventually it's done. And we're actually able to catch when it's done. As a matter of fact, I called it a pending thread. Bit of a hacky solution, bit of a temporary solution, but it works. A process has a pointer to whatever pending thread it has. And that pending thread has this I think needs to go, by the way. At the very least it needs to go down here. Not like that, just you. Okay, so yeah, it has a pending thread. So, file system, module loader, right? You try to load your /shared onto the file system. Well, the file system in the kernel, in kernel space, is going to check the module that you gave me. If I'm not the owner, if the kernel is not the owner, then this is a user space module. If it's a user space module, then I need to create a thread and run that thread in order to initialize it, because it has an init function. So it initializes it like that. And then it does this. It needs to wait for the module to correctly initialize itself before it adds it to the file system. Likewise, the same thing happens for a lot of other things, which right now I just marked as CBA. Right? You want to truncate a file. Well, you have to, if you're not the owner, then you have to delegate the truncation of the file off to the thread that is going to be running it. If you want to open the file, same thing. If you want to, and all of that is going to produce results. And I don't really have a way to get back here after the result has been taken. You know, I need to know, maybe back here would make more sense, right? Let's say that this has a return, this actually does have a return type. If the return type to this is 0, then we failed to load the module. We can print it. failed to load module name. There we have it. And we return false, and we never mount it, and that's it. The problem is that the process is not really running in here at all. At all. In the slightest. And I need to figure out, how do I get there? There could be there are ways, I guess. None of them seem particularly nice. There is the essentially awaiting until the process is finished. When the process finishes, then read its exit code. But where do I run that code? And what do I do? Just in general, what do I do? I'm not entirely sure how to handle that. The main reason is that while we're running all of this stuff, we're in the kernel. We already have the process that called this entire thing, you know, the one that opened the file or whatever, is currently suspended, waiting for that resource to become available. But I want that to be a synchronous operation. I essentially don't want to make anything asynchronous. I would much rather not do that. I feel like asynchronous code tends to make things a lot harder to build. And yeah, I don't want to have like a callback for when your file gets opened or anything like that. Essentially, your process is already interrupted waiting for the file to open or waiting for the module to load. But not only that, this is also waiting for the return type of this function to know whether to mount this or not. So we need to return here somehow. And I'm not sure how to do that. Kind of. I mean, maybe. I mean, I know how to do it, but it would need me to context switch or save the context of the kernel itself. Because when we return here, we need to know also, how did we get here? Where did we come from? Where did we go? Where do we go, I mean? All of that. And to return to the process that is currently blocked, waiting for the resource, once we actually have the resource available. So once we get here, this function, we need to know that this function was actually called by actually this function. And this function is a syscall. And that goes here. And that was called by our process that is currently blocked. So if I return, I need to return properly. I need to return in the correct way. I need to return in a way that allows me to properly return, and I don't know how to do that. Alright. Well, luckily, I was able to commit the code that I had, so I might as well start experimenting a little bit. I think the easiest thing that I can do the easiest thing that I can do, I can have a label here, right? Like return from thread. I just wrote the label. What do you mean unused? Relax, brother. Relax. It's fine. Now, unfortunately, we're going to have to introduce the first goto of the system, but it's either gotos or asynchronous code. Now, the question is, how do I do this? The scope of the label is the function in which it appears. That makes them useless. Not really. Well, I can do it without gotos, with a slightly weirder thing. Let me see. Save return address list. This is what I need. I can use the same context switching code to get back I don't like this solution. That's the problem that I have. Like essentially, while I'm here, before I actually start the thread that I'm trying to run, save the stack, save this address, well, this one, and then return back here. And back here to you're seriously gonna complain about unused label every single time? Jesus. That is annoying. Anyway, end up back here with the stack as it is. That's not very beautiful. That's not very pretty. That's not very nice, even. But it should be doable. Alright, first off, right now I have a panic. So if I manage to find my way back here, all I need to do is put a goto from here to here, but like properly, saving the actual address. And then I should be able to do that and not care if I haven't saved the current stack, because I am gonna panic. But at least it shows me that part 1 is done, and then I can handle the stack part. Another thing I'm gonna have to handle is this, but this honestly is leave it up to me. Previous thread. This holds the value of the process that we're trying to restore. And we can even hold the, I already have the previous process, cproc. So I can call this one cthread. Alright. So that automatically saves everything I need to save. I can get here and just restore them. Like that. I believe also with this. To get back into the context of the current process. So that should handle restoring everything. I need to handle this. I vaguely remember having done something like this at some point, but God, I don't remember how. Now I remember how. Okay. This function, pretty much. Save PC interrupt saves the program counter whenever we've received an interrupt. A context switch has happened. The previous location where we were is stored in this place. That's not the case here. We're not receiving an interrupt. We're triggering it manually. So it should be called save PC manual, for lack of a better name, I guess. And then I can do this. Save PC manual into not there. Where do I want to store it? Well, yeah, this is fine. I'm fine storing it here, but I'm gonna have to store it somewhere carefully chosen as like a parent of the current thread or something like that. Let's call it the return address. This one, which is going to be at 30 bytes times 8, 31 times 8, 32 times 8, 33 times 8, 34 times 8. All right, so 31 values here, 31 values here actually. Am I storing one too many? I'm storing one too many. Oh well. No, I think I'm actually using that one. There should be another register in here that I'm saving that I'm not. Well, whatever. 31, 32, 33, 34, 35. And then all of these are U pointers, which makes them 8 bits each. So, 35 times 8. It's gonna get stored in that location, but it's not gonna, no. Down here. It's not going to come from here, it's going to come from the stack 30. No, it's going to come from x30, which is the current return location after this function gets called, which just so happens to be, what do you know, here, but we need to skip this one. So plus 4. I can add 4 to it. Should I do it here? Should I do it? I should do it in here. That way x30 is always the same value. Add x1, 4. Alright, so I'm taking 30, the value of the return of this function, putting it into x1. I don't really need to do that. Although, yes, I do, because I'm modifying it and I want to keep the original value. I'm adding 4 to it so that we skip this call, otherwise we're always going to trigger the thread in a loop. And then I am doing this. Storing it in this 35. Then I'm returning from the value. Or I could, if I even do it better, since I did create a label technically, save PC manual PC. And just put this label here, except I can't do that. Because, yeah, the label is after the function. Never mind. C strikes again. C compiler strikes again. Alright, so never mind. By the way, I should get rid of this infinite loop, otherwise it's going to be a bit of an issue. So yeah, while we're here, call this function, use the return value from this function to save the current location, skip ahead by 4 to skip this, should panic. Once we remove the panic, we expect this to run, but we also need to store the current stack. Alright. I think that's good. I don't need to keep looking at this function all the time. And current thread was scheduled expecting a result. We have it now. That is correct. That is true. That is very true. However, I should be able to now simply, let me print it first without doing anything. Just printing the value of the current thread's return address. Alright, which I expect to be somewhere in the scheduler. Somewhere here. I can check if I do a dump after I do a run. Alright. Please work. Current thread was scheduled expecting a result. We have it now, 0. So that didn't work. That did not work. I can do is print the value by just calling put hex. Although I will be overriding x0 if I do this, so I'm gonna do it after I save it. x0, x1. Alright, so put it in x0 and call this function. That should print it when we save it. That's it. FFFC000415114B4. I must not be storing it in the right place. Was I right about 34 and not 35 before? Don't think so. Okay, I was not. There it is. And this value, I just want to check, since I need it to be the exact value. It's going to point to, come on. For a programmer, you have nice hair. What do you mean for a programmer? Yeah, actually. Well, that's very interesting. I got what I wanted, but like, I skipped one instruction. when I really wanted to skip 1, 2, 3, 4 instructions. How do I calculate that? So what I really want to do is this. Too lazy to do something about the hair. Oh no, yeah, try to take care of it. It's still a mess, but I try. Okay, so what I have is okay. Sure. And I mean, I could adjust it. Right? Looking at the hex dump, I'm here. I want to be here. Just skip ahead, not by 4, which is the 32-bit instructions, only one of them, but by 16, the 4-byte instructions. But like, I want a way to do that properly, and thanks to C, I can't just put a label, because C is like that. I can't just do I forgot where I'm even doing this anymore. Here. I can't just put a label, because this label is not recognized up here where I need it. Which is weird, because I feel like I have seen that before. Did I ask about this? Did I ask about this? Why am I getting this result? Why am I getting this result? Not this one. Not that. There's something called a label in C. I need a result for something called a label in C. See, the thing is, like, when people write certain code, they write, like, exit points for their program. Essentially like defer, kind of, but manual. No, hold on. There you go. You can do this. Okay, so I need to get the address of a label. Do not support this feature. Don't do that. Puck. Okay, listen, I cannot be bothered. We're just gonna skip by 16, which is gonna put me over here. Alright, and I'll put a to do. No, not the dump, not the dump. Run. Alright, we have a return address. It's this one over here. What did I paste? That's the old one. There we go. The first instruction of the panic, which is not as straightforward as it could be, but it works. The problem is, the panic might not even work properly, because I forgot that the panic has an argument, t, which is in the stack, which we don't have, but we're gonna have. Either way, hacking context switching into the fucking kernel. Why am I doing this? Anyway, this return address is, in fact, a function pointer. Thanks to C being shitty, I can do this. How do I cast something to a function? I actually don't know. that, pretty much. Right, I forgot the return type. Then I put just an asterisk in there. Okay, so it's actually... It was supposed to be this. Okay, I had all the words correct, I just had the syntax a little messed up. But anyway, that should return, and maybe we're gonna see a panic. Or maybe it's gonna panic while trying to panic. Somehow the thread has returned. Asynchronous. It's asynchronous. It's asynchronous. It just is. It just is. It did it. It did it. Oh my god. It worked. What do you mean? That worked? Sure, man. Sure. Anyway, the clear question is, it gave me a value here. Is that this value? Because if it is, I'm pretty much done? Which is ridiculous. Okay, let's check. I'm actually surprised that that worked well enough. It's a little bit hacky, but what isn't in a kernel? You'd be surprised how much of a kernel is just hacked together. Or not if you've worked on them. No, it's not the same value. Okay. I didn't expect it to be. I thought that would have been really, really weird if it was the same value. Because, of course, what I want to do is an entire context switch. Ridiculous. Absolutely ridiculous. Okay. Yes. Okay. I know how I'm doing this. This is ridiculous. But I know how I'm doing this. I need to save. What if I just save these? Or even just in a thread. Save all of the CPU registers, save the stack pointer, the program counter, the current status, and the return address, which is actually already stored in X30. I just need another one of these, pretty much. Where is this declared? Oh. Okay. Well. Alright, so save the current context entirely. Not just the return address, but everything. Using context switching code, but where is it? Where is the context switcher? Here. That's what I need to do. Save it to the kernel thread. Then give this one access to the kernel thread. Hold on, I have a kernel thread. Oh, that's not a good idea to do it like that, but okay, yeah, I'm gonna save it separately, right? I'm gonna have a kernel thread. What's your problem? Ah, take out the initializer. All right, and that's where you're gonna do it. You're gonna restore the kernel thread. Instead of doing this, all right. I need access to the function called save context, which for some reason, it's not a function. It's a macro. Well, I need to create a function then called save PC manual. That works for me actually. Save kernel state. All right, so save kernel state is going to do save context and return. It's a macro, so I can use it in multiple places, and it's always going to be the same. That's great. All right, so now the function name has changed to this. Nope, to this. With this pointer to the kernel thread. Okay. And then you do need to remember here to skip ahead. Restore the context from here. And clean the pending thread. Okay. Also, kernel thread. The regs 30 plus equals 16. Because I have to do that skip, which again, hard-coded skip of one function may change. Oh well. It especially will change when we're optimizing, so that's gonna be a problem. This is gonna break. But whatever. Let's see if this works. Unknown mnemonic save context. Fuck you mean? Oh, you're not including it. I guess I need to include it. Or I can just put this function in there. Because I do remember includes being kind of weird in assembly, so probably just easier if I just do it from here. Right there. That crashed. Well, it crashed in the scheduler. That's not a good sign. Ooh, boy. Line 722. Fair. How does this even work? I said I didn't want to make the kernel asynchronous, but I need to do it. There's not a whole lot of solutions to this that don't require me doing something like this. I genuinely cannot think of any. Well, yeah, some like resource management system, but I also want to avoid that. Well, like I said, this is one solution. Which I might make it work eventually, like who knows. Um but I like the idea of being able to do it like this. It's not really asynchronous, it's just doing context switching. Problem is it's doing it within the kernel as well. And the way that I did it with this kernel thread means that I can only do it in one way, but that should be fixable. Um, no, hold on. What's crashing here is not this. It's the actual execution of the program. Yep. Okay. So the problem is happening here. Save kernel state is somehow crashing everything. Despite just being a call to this thing. That's already very well tested. Although it does kind of hard code. Alright, let me see what this is doing. First off, it's masking interrupts. Selecting the stack pointer for EL1 for kernel. Then it is getting the values that it needs to get. Then accessing this value here. So x0 is not used at all. That seems like my first mistake. When this function gets called by... I see. It's getting real hacky up in here. Okay, that did something, I believe, but not really, but it tried. Okay, I have to say I'm not seeing a future in this thing. No, it's not that. It's just very hacked together. Let me try doing it properly. Even though the code I'm gonna need to do properly some other time. Here I do this. Alright, and instead of using this value, you just use x0, which you store in that. And then you access it as a pointer, that's it. That's where you store everything. And then you return. Alright, so scheduler, go back to how you were. Yeah, like that. Undefined reference to x0. That's a... Oh, I need to move. This should be a mov instruction. Okay. That is kind of better. No, it's not. Exception vectors line 84 is crashing, trying to save general purpose register x0, which of course does not. Nah, this is getting too stupid. Okay, come on, Codeberg, you can handle it. Alright. Okay, so it's up on a branch, and now I can go back to threading and start over. Here's... yeah. With callbacks. I really don't know how to do this. Context switching in the kernel did not work. Multi-threading really is so annoying. Who wants to do that? Why do you want to do that? Who enjoys doing this? And genuinely the biggest issue is the fact that I cannot run these threads as if they truly were synchronous operations. Which really sucks, because if I could do that, that would solve the entire issue. But no, because I'd be back in the same place where I was just now. I actually don't know how to handle this. Like, at all. I have zero clue how to handle this. And I know that Linux is probably doing something really, really, really stupid. So I kind of don't want to know what it is. I'm actually super out of ideas for how to handle this. Damn, multi-threading is the worst thing I have implemented in a long, long time. It genuinely sucks. It is a bad thing to implement. I am hating it. I absolutely hate all of it. It's amazing how much I hate it. How much it sucks. How horrible it is. How little I enjoy it. Okay, I'm going to try experiment number 2. I guess. This shit sucks so much. It is genuinely a disappointing thing. Multi-threading, come on. Bullshit. I forgot what I wanted to do. Okay, yeah. I'm going to try this. The entire reason why your thread can run at multiple times... I hate all about this. Oh, I hate all about this. This is so horrible. I can't even begin to explain what the problem is without hating it. I actually hate how multithreading works. Everything about it is complex for for a good reason, I have to say, because it is complex asynchronous code. But what the fuck? What the fuck? It is actually so annoying. I don't want to do this. It is a genuinely disappointing thing to do. Wow. It sucks. Alright, the other thing that I wanted to consider is like the issue that I was having with the way that threads were implemented now, without doing this whole like pending thread bullshit here. I was able to get threads working properly because of this pending thread, which essentially schedules the thread, but that makes it very asynchronous. Otherwise, it just doesn't work. And the reason for that is there's probably a pending interrupt. And the second that we try to access this thread, that interrupt gets triggered, and this thread never runs, is never given the possibility of running. But everything about this sucks, because I don't want to do that either. This, I believe, should be the way that we unmask these interrupts. No, mask these interrupts. No, not define. Include memory/memory access. This is the way that I should be able to clear that interrupt, but it's not working. I'm not sure if I'm just misremembering if this is the way to clear the interrupt, but it should be. So that there are no interrupts waiting for me the second I try to run my thread. But it never runs. However, if I put it as a scheduled thread, no, it doesn't print anything, so that doesn't help. On quit is straight up the wrong place. I'm in the wrong process entirely. Here. Well, that loaded. Oh, yeah, it loaded. Because it has a pending thread. If it didn't, an interrupt comes in as soon as I uninterrupt the thing and it never runs. Okay. I think the correct solution to this entire fuck-ass thing, this is actually so annoying, is that each process needs to know it is waiting for a specific type of operation to happen. When that operation happens, it knows to continue with the next one. It's very context aware. It has to be very context aware. There's not much I can do without making it context aware. But it's probably the best thing I can do. Essentially, when one process tells another, or when one process is like, hey, I need this resource, the kernel just tells it, okay, wait while I give you this resource. Then it tells the other process to prepare the resource. It attaches knowledge of that to the thread so that the thread is like, okay, once I'm done, I'm going to provide you with a resource. And you are going to have that resource available to you. This sucks, man. Oh my god, this sucks. I hate all about this. I actively hate all about this. Wow. Okay. It's one thing that I definitely don't want to interrupt, right? Especially interrupt. I don't want to implement right now. It's going to require a lot of refactoring too of the code. And it's going to need to make this entire process of synchronization between threads aware of the file system. It needs to happen entirely through the file system, which is okay. Because again, I want to do IPC through the file system. So in that sense, like, yeah, sure. But like, it's horrible. It's horrible. Okay. I do think this is what I have to do. I have to. When one process wants to read a file that another process owns, it asks the kernel. The kernel is like, all right, just wait. Puts the process in a queue waiting for a resource, which is how Linux does it, to be fair, how other operating systems do it. I just hate this design. But I guess it makes sense. Anything else is just too stupid to do it, as far as I know. Anyway, yeah, it's like, okay, you're going to be waiting for this resource. Once the resource is available, I'll tell you about it. And then it's like, okay, hey, to the other process, you are going to run this code, and the result of that is going to be this resource. I am going to wait for you to finish working on that, and when that becomes available, I'll give it to the other process. That's what I need to do. That's what I don't want to do. But that's what I need to do. And again, this is how operating system schedulers tend to work. I am going to yearn for how simple the kernel is right now. I will not have this. Yeah. I definitely will not have this. Now, there is one thing, at least. I'm actually sad over this. It's genuinely such a hassle to build. And most importantly, it seems like such an unelegant solution. And yet, it is the solution that literally all operating systems use for synchronizing things. I'm sure I can make it elegant, I guess. Sure. Surely I can make it elegant. At least it's only in the file system, and everything else that happens between processes will be in the file system alone. So I'll only have to do it once. But I want to, at the very least, design it properly, and I want to not implement it today or tomorrow. Tomorrow I want to work on Lisp. Tomorrow I want to do something fun. This is not fun. This is depressing. This shit is depressing, actually. The file, not the file system, multithreading fucking sucks. There's also a lot of code I need to clean up for what I already have. So we're good for now. I did say there was one thing I needed to do before I was done for the day, and I don't remember what that was. So that's not very good. Okay, yeah, I remembered. File system modules have an initializer. What if I just don't give a fuck about your initializer? How is that? If I'm not the owner, you're responsible for... Yeah, that's what I'm gonna do. To simplify this as much as possible. The file system module has an initializer. If you're in user space, you should initialize it however you want. You decide if you want to initialize it or not. Not me. So, if the module owner is equal to this, then I care about this. Otherwise, I don't. What's going on with the indentation here? Okay. That's how you do it correctly. So now it should be possible to mount the file system, because the initializer for the file system is none of my business, of the kernel's business. Maybe I'll add a to-do to revisit this thing, but not right now. That's not good. Shit. Well, actually, the module is not initialized at all, so that is the problem. Userland terminal main. This initializer can be empty. You just call it, yourself. So much easier. It doesn't take an argument though, weirdly enough, but okay. Wait. I just ran a git checkout, but I'm not on that branch. Okay, I either didn't run the git checkout or I don't know what happened. Whatever. I'm genuinely so disappointed by how all of this is turning out. Module not initializer due to missing initializer. What did I just tell you? I told you to skip all that. I told you none of that matters to you. Ah, but that's a little bit earlier. Okay. And this crashes. Oh man, what now? No. File browser.h, that's a bad start. Helpers.c syscall module loader 113. Calls hashmap module loader 101. Iterate over the root. Module loader 101, dir list. This memory belongs to someone else. Okay, that's easy to fix. We're actually going to make a copy of the module that is in kernel space. Otherwise, it makes no sense to do this. Hello, TikTok knock. Scheduler, load process module. All right, here it is. This is a copy, but I need to do like a better copy. So these can stay the same, this can stay the same, but these two need to change. So this should copy them. And avoid that issue. Still, motherfucker. Address is 0. Oh, that's not good. Would I be able to run this OS on Proxmox? Probably not. Runs on QEMU mostly, barely does that. Line 101 tries to access the module. Can you access the module? The mount point is 0? The mount... Is the mount point or the module 0? Hold on. Run the terminal. Don't close it. Oh, for fuck's sake. What now? Why is everything crashing all of a sudden? This is getting unpleasant to work on. Okay. There's my term history. Inaccessible because CBA RN. That was very accurate, but it is there. The problem is that I'm not cleaning it up properly. I am unloading most likely. Hello, cheese detonation. Load the terminal. Another window. Load this. This works. That's good. Now close this. Go to the... fucking stop hijacking my keystrokes here, Linux. Linux, you've... I'm pissed off at everything that has to do with computing. Multithreading has genuinely killed my interest in this project. I'm not even kidding. I want to continue working on the project, but multithreading has actually made me so angry at it. Multithreading is genuinely disappointing. I don't know what to say. Module loader 103. After printing that the module does exist, but then on line 10, okay, that column is absolutely useless. You're just telling me that the function itself is the one that's crashing. Line 19, with line 29. Where is line 29? It's just the function itself that's crashing. And yet I accessed the name. So what is the problem? What is the problem? I actually don't know what the problem is. It seems like you're able to access all the values that you need to access. No, there's one of them that is null. That makes sense. Why is it just one ridiculous problem after the other with this fucking thing? But it's like an actual 0 address in the module mount. Okay, so the question is this being called? No, it's not. Okay, yes, this should be unloading the current module. When I close the terminal, it should be unloading what that terminal creates. Stop process. Process has ended. But it hasn't... it hasn't actually been unloaded yet. Right, I forgot that resetting a process can be deferred. And so, really, what I need to do is just... if no module or no module mount, return. Okay, I was wondering, like, I could easily have written that code, but like, why is it happening? Because the module hasn't actually been cleaned up yet. Okay. That's good. Whereas instead, if I try to do this with the terminal open, that's a weird bug too that's also pissing me off. That is actually there. There is term history. Okay. 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 So I'm gonna add a to-do here. Well, this unload module, yeah, that makes... This isn't even a to-do. More so I need to add a note. To init and finit. For modules loaded in user space, it's the program's responsibility to call these functions. Amusing. I fucking love programming. It's the best. Suffering is a fundamental part of programming. See, the thing is that somebody earlier was complimenting my hair, and I would like to keep this hair on my head. So I need that. Anyway. Alright. Yes, I am making an operating system, and it is completely from scratch. I was working on multithreading, and how does multithreading work at this level, and what's the goal? The goal is to kill me. Through sheer fucking stress, it turns out. Okay. The thing is that I'm trying to do multithreading, and the way that multithreading works has made me genuinely disappointed in these kinds of systems. It is like the solution that I have for the problem that I'm having is not even an ugly one. It's a standard one. I think this is how Linux does it. This is probably how Mac does it. This is probably how... Actually, Linux, Mac, BSD probably do it in the standardized POSIX way. And then Windows probably does it the same way as well. I'm not sure. Can you even have user space file systems in Windows? I don't know. But either way, you do have resources that you wait for. The thing is, you have a process. That process can create its own file system, or can expand the system's file system with its own little module. That's this system module. You just create one of these, you provide these function pointers. These function pointers are the ones that provide the functionality for opening a file, reading, writing the file, closing the file, truncating the file, getting information on the file, reading a directory, and they also allow aliases. Okay, so ignoring the aliases, which is just here, but it's not part of what I'm saying, this functionality can be provided for a specific path in the file system by user space. And the problem there is that I have a process that provides, for example, a folder called shared. And in that folder there are files. Another process decides to access a file inside of that folder. So this process will need to call the open function, and then the read function, and then the close function within this process. This process will need to run those functions, and those functions can take some time to run. That's reasonable. So I'm putting them in threads. They can run, take however long they need, eventually they finish. I'm able to time them out if I want to with a kill on the thread, but I don't really need to. Not right now anyway. Maybe I'll need to time out those threads or do something like that, but right now I don't need to. The problem is, this program wants something from this one. it tells the kernel, hey, I want this thing. It doesn't even know that it comes from another process. It's just like, I want this thing. All right. The kernel's like, I know that this thing belongs to this process. I'm going to ask it to give it to me. So it's going to do that. And this process is going to run that, and then it is going to take some time and eventually return a response, which is like, here's the file ID, here's the buffer that you requested, I did the operation that you requested. Like write, for example, will not return any data, but it will return a size, and it will perform an operation. Read will return data as well as returning the size of that data. But yeah, open and close, they're all operations, and if they might take some time. So yeah, this one's just like, yeah, I did it. And it can tell the kernel, but then the kernel has no way of being like, hey, this process is waiting for that. I have that ready now. Time to talk back to this process. And really the way to do that is some sort of resource management, which I'm going to start building. I'm going to need to start building. Right, essentially when this one makes a request, it's like, okay, your request has been given ID number 34. And then it tells this other process, hey, open this file for me. And by the way, when you're done, this is attached to a request number 34. And then it, does that, and the kernel's like, oh, I have a process waiting for resource 34. Resource 34 just became available. Well, guess what, process? It's your turn. Your time to shine. And the process is going to be blocked until that moment. Sounds like loads of fun. That is exactly right. Can you tell how amazing this is? When I realized this is the only solution to this problem, I don't like it. I don't like it. I don't like it. I'm going to need to create this entire resource system. It's going to kind of need to be aware of what kind of resource this is, what operation is associated with it. That's a bit of an issue. The other thing that is also done with a similar architecture, but luckily I don't need to get any response back, is signals. Because of that, signals are just like, hey, here's this thing sent to a process. Don't care if you received it or not my problem. So I don't have that problem with signals. I have this problem with the file system. I have to consider, again, knowing this operation, knowing that one process is going to be waiting for a certain operation to happen until it receives it. And that the other process is the one that provides it. When it provides it, unblocks the other process. And most importantly, there's a whole lot of, sharing the arguments of these functions and the return types of these functions as well. Including, when there's a buffer, copying that buffer from one's space into the other's. It's interesting knowing how programs are communicating. Yeah. It's a whole thing. Okay, well, on the one hand, I am kind of relieved that I have an answer to how to do this. On the other hand, I hate the answer. But it honestly isn't even like, obviously I didn't do any research on this answer. I just know that this is how it works. So it has its benefits. Like, you can make your processes a lot smarter and a lot more resource efficient by doing this kind of thing. right? Because you can essentially block a process until it receives a specific thing. It's condition-based execution for the process. That's very convenient. But God, no. Anyway, yes, this is how this will work. And it's going to be very fun. And I'm probably going to start building it next Friday. Because tomorrow, I will be making a Lisp interpreter. Finally, something that I actually want to do. I wanted to do this file system in user space shit, but I did not want to do this. Although I have to say, I did threading. Eventually, threading ended up being done. There's still a lot of refactoring. I refactored a lot of the, like, memory management stuff this morning, actually. Well, this afternoon. I need to refactor the scheduler as well. Right now, the scheduler works off of processes. I need it to work off of threads. Threads are a little bit hacked together because I just created them. So yeah, this is a thing that's going to take a bit. But in the meantime, I'm going to be building a Lisp interpreter, and I'm going to be able to write Lisp in this thing, and everything's going to be smooth sailing with Lisp and multi-threading from now on. So it's going to be great. It's going to be great. It's going to be so great. Yeah. Whoa. I'm so excited. Okay, yeah, yeah, the whole solution is not even too bad. I am mostly telling myself that I am trying to convince myself, I'm trying to get myself on board that this is gonna be okay. That it's worth doing. Yeah, it is. It is worth doing. Yeah, I just need to stop whining and start doing it. That is it. Really. For multi-threading this week. That is more than enough. Thank you very much. It has been a pain. I have not enjoyed much of it. Can't imagine anyone has enjoyed much of it when I'm not enjoying it. Well, unless you enjoy watching people suffer, in which case you are enjoying this right now. I'm happy for you. However, I am not enjoying it. And I'm not getting paid for this, so I might as well enjoy what I'm doing. What can I say? Yeah, so I'm gonna take a break from this whole thing until Friday. Tomorrow I want to work on this Lisp interpreter. I was hoping that maybe I was able to do this and finish it by today, but yeah, that's not gonna be a thing. I don't want to make it a thing. I want to take my time with it. Microdose it until I build immunity to multi-threaded code. It's just so unenjoyable. It is so sad. One thing that's for sure is I've never enjoyed multi-threading. Does anyone? Probably. But yeah, this is not very fun. Anyway. Yeah. That's it for now. Tomorrow it's Lisp. I was thinking about it a little bit. Let me at least like get myself in a better mood by talking about something I actually want to talk about for even just 5 minutes. I was thinking a little bit, and first off, I added semicolons to my compiler's parser generator, pseudo parser generator, because it doesn't really generate the parser, it just generates data for the parser to then parse. But makes it a lot more readable instead of what it used to look like before, which was this. I find this syntax a lot more readable for my program, and technically I can make it even more readable if I just do something like this, for example. And I'm sure if I like work on the LSP a little bit for this thing, I can also make it understand indentation properly, because it did not seem to understand how I wanted my indentation done there. But yeah, I find this to be a lot more readable, even though I wanted the language to not have semicolons. I kinda don't care anymore. Now that I've worked on Lisp, I've seen the light when it comes to programming. Semicolon versus non-semicolons is unenlightened behavior. There's so much more to talk about when it comes to programming, and none of it has to do with whether your code should have semicolons or not. I'm unironically becoming the Lisp equivalent of a Rust fanboy, by the way. Lisp is just that fucking good. Lisp deserves it. Lisp is actually the language that was promised. It is just that good. It is just that great of a language. But anyway, I was thinking about my compiler, and it's actually perfect for handling Lisp. Because like the way that I build my rules, again, there's a name for these kinds of compilers: recursive descent, recursive whatever. I don't know. But the way that my compiler builds an AST, or the way that essentially it interprets the program into a tree-like structure, which is actually just a stack, it does so. For example, this is a block which is just any code, any line of code, is made up of a statement followed by an optional second block. And I was talking, when I talked about Lisp, about the concept of car and CDR. Since Lisp is a list processing language, the first element of the list is car, and the next elements of the list, all of them, are in CDR. Right, so you have a list like 1, 2, 3. This is car, this is CDR, and I was just thinking, the language itself follows these rules as well, which makes it very metaprogramming. This is car, and this is CDR. So that makes it kind of very convenient for me. Feels like this is the correct type of parser that I'm going to want to have in my Lisp interpreter. It seems very easy to parse. Lisp is fun, mega easy to parse, but I don't see why linked lists are a great idea. My performance brain is not happy. I do agree with that. I do agree with that. And I want to take it further. I want to experiment a little bit. Again, that's the cool thing about a compiler that has syntax like the syntax, dynamic syntax kind of. I want to take it further to where it's real dynamic syntax. It can change without recompiling the compiler. Currently, that's not the case. Don't really need it, but I have a plan for doing that. I just CBA. Don't really need it. It compiles pretty fast. I forgot this was happening. That was like a lot of errors. I must have configured something wrong. Yeah, because this is not valid. But essentially, that file compiles to this C code. And then this C code... It's like really, really long? This feels extra long? Yeah, something broke. Something broke. Yeah, something super broken here. Holy fuck. I broke something real bad. I am not interpreting the right language for once. Okay. Yeah. So this is all it takes to rebuild the rule generator for the parser, the compiler, and then for the compiler to compile something. And the entire thing takes a second and 357 milliseconds, where the compilation of the compiler is 14 milliseconds. The rest is just GCC being slow. Oh well. But anyway, thanks to this compiler being so dynamic, I want to experiment with other languages doing syntax similar to what Lisp is doing, but without the list-based thing. And also, I was talking about like wanting to do text processing. What is APL? I wanted to I've heard of that. Wait, it's one of the precursors too, isn't it? Yeah, I wanted to do text processing, and I was talking about regular expressions are doing text processing. It's just that the interface through which you do it, the regular expression, is completely unreadable. But the way that it's done is not too bad. Like the finite state machine that I have running behind it is not too bad. I was thinking, do I want to make another interface for it? A more programmy but cleaner syntax that helps me parse text in a simpler way. So that's one thing that I want to do. I want to play around a little bit with the thing that most low-level languages, including Lisp, I believe, were built for a specific machine, original machine. And so they were built with that machine's architecture and that machine's paradigms and that machine's, not even limitations, but just like the way that that machine worked. So I want to do the same thing. I want to just experiment with languages, essentially. So yeah, I want to do the same thing, but with ARM. Something that makes sense for RISC style assemblies. All right. I do want to see what APL is. It's very similar to Lisp, actually. Oh, John McCarthy. No, John McCarthy was influenced by the information processing language. This is the... No, wait, this is the Lisp page. I want to know what APL is, and then I'm reading about Lisp. But yeah, he was inspired by this. Okay, so yeah, tomorrow I'm going to look a little bit at all of this stuff. I just want to know what this looks like a little bit. It feels very functional, from what I'm seeing. Functional array, nihilatic, monadic. They start inventing words. Can't stay at my PC too long, but it's always fun to see the progress you've made. Well, glad to have you. I'm leaving the stream anyway. Yeah, I'm ending the stream anyway. This is my second stream today, because I thought maybe I'm gonna be able to do this, and it's gonna work well, and it's not gonna be a problem. But yeah, the way that I was going with that, could have worked, sure, and would have required less work, sure, but it would have been stupid, sure. Anyway, it is a programming language. Game of life in APL. Okay, hold on. This is it? This is the game of life? Brother. Okay, I'm looking at this tomorrow for sure. Again, what I'm doing is a Lisp interpreter, but I definitely want to do a little programming language exploration thing as well, eventually. So, yeah. That's all the logic needed to update the board. Okay, so it's not... Like, am I able to just run this? If I just take this code, copy, paste it, not write any more code, and run it? Is that because the interpreter handles all the important stuff? Or is there other code besides that? I mean, obviously, yeah. But yeah, doesn't matter. I'll read this better tomorrow. Very interesting, though. I have to say, that is completely incomprehensible to me. The aliens programming language going on here. What is that? What is that symbol? What is this? Oh my god. I've actually seen this in crop circles. Okay, it doesn't count as a concise programming language if you use alien symbols. That doesn't count. I'm sorry, but it doesn't count. Alright, I'm gonna look at this tomorrow because I definitely want to know what the hell is going on here. But yeah, the main plan tomorrow is to implement a Lisp interpreter. I am so much more excited for that than I am for multithreading. But honestly, now that I have a clear vision of what multithreading is going to be like, I guess I'm okay with it. I have until Friday to make my peace with it. Alright, and anyone who doesn't like Lisp has until tomorrow to make their peace with it. So, I will end the stream now. You still need the code to initialize the board and to code to print the board. Okay. I was wondering if is that... Because, like, I could make a language called Game of Life, where you literally just need to call life, and the interpreter for the language does the entire process for you. That's not super impressive. More so, it makes the language kind of useless for literally anything else. But, yeah. Still interesting that this is how you do that. Alright, and I believe the language probably has some interesting stuff that I'm gonna check out tomorrow. Alright. So yeah, before I keep yapping and an ad starts, calling life in MATLAB makes it run Game of Life. There you go. There you go. That's what I'm talking about. Alright, thank you so much, everybody. Finally, I am free of multi-threading until Friday. I get to enjoy myself tomorrow. That's gonna be so fun. I am gonna cry from how happy I am. I just looked at the name of the developers of this thing, and it's very interesting. Alright, thank you so much. I'll see you tomorrow.